Hey y'all. Today we're going to learn about two really important concepts within electrochemistry. Today we're going to learn about electrolysis and Faraday's law. So let's go ahead and get started. Okay. In the last video, we talked about how you can take non-spontaneous processes and make them spontaneous by coupling them with a spontaneous reaction. Electrolysis is a little bit different, so let's talk about it. In an electrolytic cell, your E value is actually going to be negative, which means it's a non-spontaneous process. But instead of coupling it with another reaction, instead we're going to drive it using an outside voltage source. So if we apply enough voltage, we can make a non-spontaneous process still happen. Think of this as rolling a ball up a hill. If I need to roll a ball up a hill, I need to exert some force to make it happen. But I only have to exert just enough force to overcome the energy that's essentially pulling the ball back down the hill, that gravity. With electrochemical and electrolytic cells, we have this energy. With electrolytic cells, it's a non-spontaneous process, which means I have to exert just enough energy to make that process occur. There are three major ways that we will see electrolysis in action here in AP Chemistry. Let's talk about all three. The first is electroplating. Electroplating is a process by which we deposit a layer of metal atoms onto a cathode, and that cathode, where reduction is occurring, can therefore be coated in a single layer of atoms of this metal. So we do this with like chrome plating. So if we have a chrome plated thing or a gold plated thing, what we've done is we've added a layer of atoms of that metal on top of, well, something that's not that metal. The second way we use electrolysis is to purify metals. So we can use an electrolytic cell to be able to take a impure metal, like say copper ore, where it's got copper but other stuff in it too, and make sure that we extract only copper atoms out of it so we can purify that copper ore. We can also reduce corrosion in this way. So if we have corroded metal, we can use electrolysis to remove that corrosion on that metal as well. And finally, we can use electrolysis to produce gases. Oftentimes we will be electrolyzing water, and in doing so, we can produce both hydrogen gas and oxygen gas. And that's a way of getting pure hydrogen and pure oxygen gases out of a water solution. So again, the big three techniques we use electrolysis for, it's going to be electroplating or plating out metal. It's going to be purifying metal samples, or it's going to be the production of gaseous products. Faraday's law really, in the end, comes down to just a single equation. Now, Faraday's law is bigger than this equation, but as we need to understand it for this class, Faraday's law can be summed up with the equation I, which is your current, in amps, is equal to Q, which in this case is charge, okay, in coulombs, divided by T, which is time, in seconds. This is an equation that is on your formula sheet. You do not have to memorize it. In fact, not only is the formula on your formula sheet, but it also discusses exactly what each of those variables represents. The Q here, remember, is not the same Q as it was in thermo. Back in thermo, that little Q represented heat. In this case, it represents charge. It is different. Same variable in terms of the letter, different meaning. Okay, so just be careful with this. If you ever get confused, look at your formula sheet. Both Q's are represented on the formula sheet with the correct equations. The other thing to be aware of with Faraday's law is that there's a new constant. This constant is 96,485 coulombs per mole of electrons. So if I have a mole of electrons that move through a wire, that is going to contribute 96,485 coulombs of charge. When I look at amperage or amps, this is the current. So the Faraday's law here, the equation that we're looking at, is going to tell me what is the number of amps that is going to be moving through a wire. And that's going to be judged in, well, coulombs per second. So when we have amps, the unit of amps is coulombs per second. Right now, you need to know the equation because of the fact that in the next couple of videos, we're going to learn how to use this equation. It actually comes back to utilizing it mostly in dimensional analysis and stoichiometry. So we're going to do a lot of examples of that as we go forward. But this is an equation to be familiar with, but also to understand is on your formula sheet, so you don't have to memorize it. So that wraps up today's video. Let's do a quick recap. Today, we learned about electrolysis and Faraday's law. Electrolytic cells, remember, are inherently non-spontaneous. In order for them to occur, an outside voltage source must be applied. When we apply that voltage source, we're going to cause the reaction to occur, even though it's not spontaneous. Faraday's law gave us the opportunity to calculate a new value, amps. Amps is the unit of current. And remember, that equation for Faraday's law is on your formula sheet. You don't have to memorize it. Today's video was written, directed, produced, and edited by Owen Belcher. I'd like to thank you all for watching it. I hope you enjoyed it, and I'll see you in the next one.